everyone. Thank you for joining us for this event. So today we have an event called Science Magic. It's not your imagination. So in this event, we're going to be doing some fun science experiments that look like magic, but are actually based on science. So today we have Kathy Foster from Techno Kids, who's going to be showing us the different experiments.
Hi, everyone. I'm happy to be here tonight. I'm looking forward to some really fun some experiments that we're going to do. I just wanted to share a book that I had that I got a lot of these experiments from. This is called Science Magic by Stephen Mould, and they're really very easy to do. Most of the materials are from things that you have laying around the house. They're safe. I would highly recommend this book, and I'm sure that at the library there are many other great science magic books that you can check out at a different time. So I just wanted to kind of share where I got some of my ideas from, and we're going to do some really fun magic tricks, but they actually are based on science. So I'm also gonna kind of show you, most magicians don't show their tricks, but because I'm teaching you how to do this, you're going to learn how to do these magic tricks so that you can surprise your friends and family with some of these cool things. So let's start with the first experiment. So the first experiment before we start our first experiment, we need two things I need to tell you about. You need a magic wand to complete these things. Now, my magic wand is very fancy. I am using a pencil. It can be something as simple as a pencil, or maybe a chopstick or a stick that you have that you found outside. You could decorate it if you want to, put a lot of glitter on it, or it could just be basic like mine. Okay, and we need some magic words. And so today our magic words for our science experiments are going to be science is magic. Okay, and so with that, we'll start with our first science experiment. So for the first experiment, you are going to need a dish of water. Okay, and in this dish of water, I am going to add some pepper. Okay. Now, scientists, even though these are magic tricks, we're going to talk about science today. Scientists use their observation skills. Okay. So if we look at this, we see that the pepper is floating on top of the water, right? And that there are a few things that are falling to the bottom, but most of it is just floating on the surface. Okay, so I'm going to make this pepper move. Okay, abracadabra, science is magic. Okay, I'm going to stick my finger in the water, and what do you think might happen? Oh my goodness. Guess what? Nothing happened. I have a big deal, right? I have a few things of pepper on my hand, on my finger, but nothing major happened. I better try that again. Abracadabra. Science is magic. Now I'm going to stick my finger in it again, and hopefully we'll have some magic happen. Ready? 1, 2, 3. Boom. What is happening? Can you see? All the pepper is going to the side. What just happened? What is the science of that? That was pretty cool, huh? So I'm going to tell you the trick. So what I did was I put the pepper on with the water, put the water in the bowl, put some pepper on it. The first time I did it, my hand it was regular. It was just regular. On my other hand, I put a special ingredient. I put some Dawn dish soap on my finger. And what the science is of that is that the surface tension. So what happens is the layer on top is stretchy like a balloon, and the surface pulls back with the Dawn dish soap. Now, if you use wash dishes, what happens? All the oil goes away. All of the dishes become clean. That's the property of the dish soap. So with one hand, If you want to do this experiment again, you have nothing on it. The other hand, you have a little bit of Dawn dish soap, and then all of the pepper will go to the side. That's pretty cool, isn't it? I have another experiment that has the same science behind it. It is surface tension, but it is a little bit different. So I'm going to share you that one too, because that one's a really fun one too. So I am going to put that one aside. And I have, in this experiment, I have some milk, okay? And I am going to add to this milk, I am going to add some different food coloring. Now, I want you to just watch and observe what happens when I add the food coloring, okay? Make that stop. All right, so I'm going to add some red food coloring. I'm going to add some green food coloring. Quite a bit if you want to try this at home. I'm going to add some yellow food coloring. Now you notice, and I'm going to add some blue food coloring, okay? And I just randomly put it all over. There's no rhyme or reason to where I put it. And if you observe this, you can kind of see that the food coloring it's wanting to kind of move, but it's kind of staying in its own spot. Once in a while, the colors will all mix together, but basically it is staying in its own spot. So this time for a magic wand, I'm not going to use my fancy dancy pencil. I'm going to use a Q-tip. And on this Q-tip, if the science trick, if you're doing this as a magic trick, you're not going to tell anyone, but on this Q-tip, I have some Dawn dish soap. So using your scientific brain, okay, what do you think is going to happen when I add this wand to the food coloring? You can talk amongst yourself and figure it out, all right? And now I'm going to do the trick. Ready? So if I did it with this side, if I did it with this, nothing really happens. But with the side with the dish soap, abracadabra, science is magic. And what happens? Look at what's happening. All the colors going away from the Dawn dish soap, isn't it? It's repelling. It's going all the way and it's mixing together, forming a beautiful like marble effect, right? Didn't do that before. So that is our science experiment about surface tension, okay? All right. Are you ready for another experiment? That was pretty cool, wasn't it? All right. Our next experiment, this way here, is going to be, it's called a no leak bag, okay? And so I'm going to amaze and astonish you with my great skills. So I have here a bag of water. Now it's wet on the outside because I practiced it and I use this as a, so I have here a bag of water. And if you see, it's not leaking, nothing is happening, right? Okay, so I am now going to stick these pencils through this bag of water. What do you think is going to happen? Scientists make hypotheses. Magicians just let it happen. So, you ready? So let me just tell you this, that your pencils have to be very sharp in order to do this, all right? So I am going to, with my magic trick, I'm going to put this pencil through the bag. You ready? 1, 2, 3. Abracadabra, science is magic. Look at that, not one drip. Should I try another one? I'm gonna. It's a little scary because on my computer, if it doesn't work, it's gonna be a problem. Ready? 1, 2, 3. Abracadabra, science is magic. Whew, that was a close one, but it went through, not even a drip. What is happening? Ready? 1, 2, 3. Abracadabra, science is magic. Woo! Ooh, I sprung a leak on that one. So I'm gonna have to see if I can stop it. Oh, look, I stopped it. I don't know what happened, but there we go. So I'm gonna stop right there while my luck is happening. And very good. All right, so let's talk about what just happened. I'll put this to the side here. So probably the best idea to do this experiment would be outside, and make sure you ask your parents before you do it, because it can be a little bit messy, as I'm seeing right now, because I did have a little bit of a leak, but it's all is good right now. So with that, we'll go on to the next experiment. Okay, let's see. One quick second here. I gotta wipe up my mess here. Like I said, this one would be a really good one to try outside. All right, so let's talk about the science of that one. So what happens? So the plastic bag, okay, it moves, the plastic moves to make room for the pencil to go through. It stretches and it seals it. Now, if you used a paper bag, obviously it wouldn't hold water, but if you tried to put a pencil through a paper bag, would you get a clean circle through it? No, it would kind of form a rip. So the idea is that the material that is made out of a plastic bag, it's called a polymer, it moves and makes room for the pencil and then seals itself up. So that's the science behind that. That was a pretty good one too, wasn't it? All right, so that's my next one. So this one, let's see, I have another one. Oh, this is a really fun one. This one is called the Chopstick Challenge. And I need to, again, wipe this down a little bit more because we need a dry surface for this, okay? All right, so I have here before me two identical bottles filled with rice. Now this one will be good if you had a assistant, okay? And if you had an assistant, you would say, I bet that you cannot lift up a bottle with a chopstick. And you say, and then you'd say, I bet I can. But because I don't have an assistant, we're gonna have to do it this way. So I have two identical bottles here. With this, I have an ordinary chopstick, okay? I am going to try to lift this bottle with a chopstick. Nope, not working, okay? Do that, not working. So now I'm going to try to do this one. Oh, I got the wrong one. Now I'm going to lift it. Ready? Voila, there we go. Let's try it. Lift it up with just a chopstick. How did I do that? Pretty cool, huh? This one, no, I was doing the wrong one. So that one, no. This one, yes. So what is the science behind this experiment? So the science is that one of the bottles I filled, they're both filled with rice. They're both filled to the top, but one of them I filled loosely. This one that I could lift, every time I filled it, I would shake it down. And so what's happening is the friction, when it makes it harder for the objects to move. Since the loose rice doesn't push, there's a lot of room in the jar, so even though it looks full, there's still a lot of space in between it. When you press down, because the rice is hard, is very small, it becomes compact, and the friction, it pushes hard on the stick, and the greater friction stops the chopstick from sliding out. So again, you can amaze your friends by doing that. Have them do the one that comes out that won't stick. Now, let me just tell you a little fact about this. If you keep on doing it, eventually you probably will get it because they'll pound back down. But the one with don't shake it and the other one you just keep on pounding it down like that. That is the secret to that trick. All right. So that is my next experiment. That's not my last one yet. So I have another experiment that is about static electricity. Okay. So I have a snake made out of tissue paper. Can you see that? And I am going to make the snake dance. Okay. And how am I going to do that? First, I'm going to take these balloons. Now, we know about static electricity, right? What's one way? So what happens is when the balloon is rubbed, when you move it on, you do it on your hair. What happens when you rub your hair? It starts sticking up, right? That's static electricity. It has the negative charge to a positive charge, right? So what's going to happen is I'm going to try to get the electricity, and I can lift this snake with my balloon. Pretty cool, huh? Try it again, like that. And there is the static. There it is dancing. Pretty cool, huh? All right. That was a quickie one, but it's a good one. Again, the science is that the positive and negative charge are attracted to each other, so the paper is attracted to the balloon. That's what the science is of that, okay? Again, to make this little snake, all I did was I took a paper plate and a piece of tissue paper and I made a circle, and then I just cut. Can you see, I made a little like, with a pen, I just made it like a little swirly, and then I just cut around it in a swirl like that. And that's how I made my snake. Now, you don't have to make a snake. If you want to make something else, or just cut little pieces and see what happens, you can do that. And again, it's about the illusion that it's dancing. So yeah. All right, and then let's see. I have one more experiment, one grand finale experiment. This is called the color changing magic potion. Okay. And I have before us, I went around, this is my color changing potion. You can see that it's purple, right? Okay. And then what I did was I went around my house and I looked for different liquids. And I tried to choose liquids that were kind of clear so that you could see the results. So I chose Mountain Dew. I chose some tea, white tea. I chose some vinegar. Okay, and some baking soda and water. And some dish soap and water. And I squeezed some some juice into a cup. So that's from an orange. So what I'm going to do, one at a time, I am going to change the color of each of these liquids, okay? Now, again, this is with this color changing potion here. This is my magic potion, all right? So let's see, what should I say? I guess we'll start with the Mountain Dew. So the Mountain Dew, if I observe, I see the Mountain Dew is yellow in color right now. And if I add this purple to it, watch what happens. You ready? Abracadabra, science is magic. What color did it turn? It turned like an orangey pinky color, right? Okay, so there we go. So do you think all of them are going to change the same color? We'll see. Okay, the next one I'm going to choose is the dishwashing soap and water. You see the bubbles on top? Okay, here's my purple magic potion. Abracadabra, science is magic. What color did it turn? It turned like a blue color, blue-green color. What? Same purple stuff. All right. Are you ready for another one? How about vinegar? Right now, the vinegar is clear. My observation is that the vinegar is clear. I'm going to add my purple magic potion. Abracadabra, science is magic. Boom, it's like a pink color. So I have an orange, a pink, like a blue, purple, all out of this purple. What is going on? All right, I have some baking soda and water. What is your prediction? What color do you think it's going to change? Let's see. Ooh, this is a pretty color, like a bluey color. Isn't that neat? So I have a couple that are on the pinky orangey spectrum and a couple that are on the blue-green spectrum, right? Can you see that? All right, I have to add a little magic juice to my cup. I'm out. Do that. Okay, I'm gonna put these aside just for a minute so you can see. I have some orange juice. Okay, let's see what color the orange juice will turn. Ooh, that's like a real purpley color. Okay, so they're all turning different colors. So what just happened? What is the science of that? It was very cool, very fun. This purple juice is the ticket, okay? So when you, there's certain foods or certain things, not even just food, there's certain things that when you, well, I'm going to talk about foods right now just because it makes, then you'll be able to make a connection. Things like lemonade, when you drink them, they taste kind of bitter and sweet, right? Or just a lemon without the sugar. So it tastes very, you pucker, your mouth puckers. That is very acid. Now we're talking about the substance. We're not talking about like an acid that is going to hurt you, but in your stomach, it feels, sometimes you get a tummy ache from it and things like that. There's other things that you eat that are very, what they call basic, and they don't have a lot of acid in them. And that's what, and so that this right here is what we call an indicator. And this indicator lets us know if something is acid or base. And you can see that the ones that are more, the red and the pink colors, those are the more acid foods, which is vinegar, Mountain Dew, and what was this? Orange juice. And then the ones that are more basic are the ones that are more the blue or the pink color. Dish soap and water, not that you would eat that, but that is a more basic ingredient. And then the baking soda and water, again, that's blue, that's very basic too. So what is this purple magic potion? Okay, now I didn't include this in the list because I needed to give you a little bit further direction for this. So this is a very natural thing. What it is red cabbage, okay? And so what I did to the red cabbage was that I boiled it. So I cut it up into pieces about this big. And so if you want to try this at home, it was really cheap. I paid like 99 cents for a whole cabbage, and I have lots of this magic potion. And you boil it, okay? You boil it, and I'm going to show it to you right now. And this, the indicator is what is kind of like a neutral thing, and it helps you tell the color. Now, if in some science classes, if you take in science in school, you might have done an experiment like this, but you might have used something called litmus paper. If you have a pool and you test and see if it's too much chlorine, if it's red, if it's too much, or blue, if it has to be right in the middle, right? That's kind of the same idea of what this is, except we're using natural ingredients. So after I boiled the cabbage for about 10 minutes, here's my pot, and it doesn't smell very good. I'm just going to warn you that it's not a very good smell. But there I have all these leaves that are all boiled up, and all the juice came out of it. And then you just strain it and you use it, and you can stick it in the refrigerator, and you can try many different things, many different liquids. You could try things like mustard and see, I think that if it's a clear, like a liquid that's clear, you can see the best results. But you can do all kinds of test out all kinds of different things around your house. So with that, that is the end of our very fun experiments, and I hope you learned something. You can do these at home. They're very easy to do. If you watch the video again, it has all the in the list. It had all the things that you needed to complete, everything except for this last one. But they're pretty easy to do, and they're pretty fun and exciting. So with that, I hope you have a good night, and I'll see you soon. Okay, bye now.